Good morning, everyone. So, welcome to the next lecture on machine learning. This is my second lecture. And one thing I forgot to mention in my first lecture that all my slides having the content that has been taken from various different sources. So, in last lecture, we have finished at comparison relationship between the different trending technologies. Like we have found that the artificial intelligence is a bigger domain, and inside the artificial intelligence, we are having subset as the machine learning. Then we are having deep learning is a subset of machine learning. Then data mining and data science is a bit overlapping with machine learning, and it has its separate domain. Particularly, we are focusing on data in case of data science, whereas in machine learning, we are more majorly focused on the learning algorithms. Then we may have my data size is big as I'm having different kind of data available on internet or different sources we are having. So we have large amount of data available with us to process. So today in today's lecture we are going to discuss about data only. So data we are using in machine learning that can be in form of numbers. First is in form of numbers. Then it can be a biological data. Biological data is like you are having a blood test report, or you are having some um, ECG reports, or you may have EEG signals, or you may have some diabetes test report. So like that, this all comes to the biological data. Or you do some experiment on plants. You do some chemical reactions, and with that chemical reaction you will get some outcome. So that may be like plant disease identification you do. Then we may have a geographical data. Geographical data may we are having satellite images. We can have satellite image, or we have the time information with time, how my agriculture, how my crops are growing, or how many changes are in soil. So this all I'll say is a geographical data that we with the change in place, how my land is becoming fertile or infertile, kind of thing, that goes to the geographical data. So it may be geographical data, may be images, or it may be a sensor data, or it can be in form of videos, or in the data captured by the drone. This all goes to the geographical data. Then we can have electrical data. In case of electrical data, this data is in form of signals, different electric signals we want to process. Then we can have motion tracking, as we discuss about the self-driving car. So in case of self-driving car, at real time we want to identify different signals, or the crowd or the obstacle coming in front of my car. So we want to process it in real time. So we want to track every object what is coming in the way of my car. And at real time, I want to identify that particular object. Next is my financial data. In case of financial data, it is a prediction about the stock market. So you are having at different time span, or at different dates, your stock market, the price of stock market is varying. So you'll be the most important thing is the date, and then you are having the timestamp, and how the market is going up and down. Or there's one called SP index, that is a very important factor in case of financial data. The financial data prediction will be done on the basis of SP index. So this is basically a numerical data, but it is in tabular form. we are having data. In case of machine learning, my data is in matrix form. I'll be having a matrix, whether it is a signal, whether it is a image, whether it is a numbers, or whether it is a financial, any kind of data, it should be stored in the form of a matrix, and it's a large matrix. So all the rows in my matrix are called my experiment. As many times you repeat your experiment, that many different values of rows you'll get in the case of in this matrix. And my columns are called here is the features. Features are the things on which my outcome is dependent. As I told you, in case of financial data, my outcome is dependent on SP index, it is dependent on the date, it is dependent on time. So I'll say the features in my data in my tab matrix is, I'm having three different columns. One is for date, one is for time, and one is for SP index. Then you'll be having output corresponding to these particular features. So, and the number of days you collect your data, like you have collected a data of 1 year. So, if you have collected a data of 1 year, there will be 365 rows present in this particular data, and the columns will be, you will be having date, time, and the SP index. Then you will be having one outcome column. What will be the price? How the prices are varying according to time, date, and the SP index. So every data, whatever, whether it's electrical data or biological data or geographical or number, anything, it should be in matrix form. In case of machine learning, in that matrices, the column represent the features and the rows represent the number of experiment you are conducting. Then in case of weather data, again weather is highly dependent on time and date and time. Then I have the weather forecast. Weather forecast is dependent on the, I would say it is dependent on temperature and humidity. There are most important factors is temperature and the humidity. So based on the temperature and humidity, we are going to predict the weather. So temperature is your a numeric quantity, and humidity again is a numeric quantity, on the basis of which we can predict the weather. Then again we have gaming data. Gaming के case में you will be having videos, you'll be having images, or the game scores. You can have the game scores on different time, how many clicks are there, or so it's a mixed kind of data. You'll be having the videos, you'll be having some numeric data, like on how many clicks you'll be getting this much of score. So such kind of things. So you'll be having certain numeric columns, you'll be having certain images, or on this particular position of the game, on this screenshot of the game, this is a winning position. So this can be a image kind of data, or you can have videos even, the full game playing. And on internet, you are having variety of data available. There is a textual data, like if you are collecting your data from the social media sites, so you'll be having different conversations available, or different, you can have review matrix if you are going with the product website. So there are different reviews given by different users. Or you may have, if you are on movie website, then you are having user ratings, the data may be user rating. So likewise you are having different kind of data. But whatever is the type of your data, it should be in a matrix form. In machine learning, we used to process all matrices. All my data is in matrix form. So let's see how the matrices are there. So Like this is my data set, this is my own data set. We have collected this data in 2019. We want to predict diabetes. This work is on prediction of type 2 diabetes using the machine learning classification algorithms. So what we did is we first identify that on which factors diabetes is dependent. So like if we see there if the person is having age more than 45, there's a high chance then that the person is diabetic. Or uh, in different genders we are having a portion of diabetes. Or those who are having a family history, those mother, father, or grandparents are having diabetes, they are more likely to be diabetic in future. Or those who are having some problem with the high BP, those, so they may have diabetes. Those who are not physically active, they may have chance to get diabetes. Or those whose EMI is more than 25, like those goes to the overweight or the obese region, they are likely to get diabetes. The smoking again enhance the chances of getting diabetic. Alcohol is again increasing the chance to be diabetic. Those who are not taking a proper sleep, they may be diabetic in future. Or while the sleep time, though you are sleeping for 12 hours, but at every hour you are waking up. So if you are not having a sound sleep, so although you are on bed for 12 hours, but you are not taking a sound sleep. So how many hours you are sleeping well? Like 3 hours you are having a sound sleep. So that will be my important parameter for prediction of diabetes. So this data is basically, this is having a age variable. So age can be a numeric quantity, like we'll say one person is of 30 years, 25 years, 45 years. So what we did is we have not taken it as numbers, because people used to write 40 as FORTY. So rather than giving this option, what we have given them choice, we have given the range of age. So this kind of variable we used to say it's an interval kind of variable. This is interval kind of data. So this interval kind of data, how we used to process is we used to take the mean of them. So like I am having a range of 40 to 49. So I would say these guys are of age of 45. And taking a mean, because exact age is not going to help me in prediction of diabetes. So what I'll do is I'll take interval data. In case of interval, what we'll take is we'll take the mean of both the interval. Then second is my gender kind of data. So gender can be either male or female. So we say this kind of variable, this is my categorical variable. Categorical variable is there are two categories here. One is the male, another one is female. So I can encode these two categories as 0 and 1. While processing on machine, what we'll do is I'll assign a number that 0 and 1, because machine cannot understand this male and female. Whether you encoded M or F, even though machine cannot recognize it. Again, the family history, we are saying the family is having diabetes or no. So this is yes or no. So again, I can encode this yes or no as 0 and 1. Then high BP, again, true and false. This is again a categorical kind of data. So I have 0 or 1. Physically active, a person is physically active or not. Again, in this one, this is again a categorical kind of data, but we have three different categories. If a person works for less than half an hour, more than half an hour, or if they are working more than um, more than half an hour, more than 1 hour. So we have three different categories. So I'll encode this as 0, 1, and 2. Again, this is a categorical kind of data. Then we are having BMI. BMI can be a number. I can have a number for BMI. This can be 15, 25, 30, 35, 45, whatever it is. Then smoking again is a categorical data. This is 0 and 1. Alcohol 0 and 1. Sleep I have. Then I ask the number of hours. How many hours a person is sleeping. So the minimum is 4 in my case, and the maximum we are getting as 11. So maximum a person is sleeping 11 hours, minimum a person is sleeping 4 hours, out of which sound sleep is like 0 hours. Somebody is never sleeping sound, never have a sound sleep, and somebody is having the whole 11 hours he is sleeping as a sound sleep. So these all are my uh, I would say whatever the variables we are getting here is, I'll say these are my independent variables. These all I say it's a independent variable. And what I want to know is I want to know the the person is diabetic or not. So I want to do the diabetes prediction. So again, diabetes prediction is what is my categorical value. This is categorical. I want to say whether a person is diabetic or not. So I'll be having 0 and 1. So what are the features, how the values are varying, how my this independent variables are varying, and my diabetes is dependent on these independent variable. So I'll say diabetes is my dependent variable. In machine learning, whenever you want to make a build a machine learning algorithm, so first thing you want to identify is the independent and the dependent variable. Independent variable is on which my dependent variable, so whatever the prediction I want to do, like I want to predict diabetes here. So diabetes is dependent on age, it is dependent on gender, it is dependent on family diabetes, it is dependent on high BP, BMI, smoking, alcohol, and the sound sleep. So these all are my important features. I would again say these all my features. The name of columns, as I told you, the name of columns, we say they are the features of my data. These all are the features, and the number of experiment, the number of times I have collected the data, that is rows, that is this one is my row. As many rows I am having in my data, so like I'm having 4 rows here. So these are my number of experiments, number of times I have taken these values. These are my number of experiments, number of times I repeated this experiment, the same values. So the first we'll decide about the features. What is the important features for prediction of this particular dependent variable, and um, these independent variable I'll collect through multiple experiments. So the number of experiment I'll do, that will be my rows, and the number of features I'm collecting, that will be my columns. So this is my data in case of machine learning. This one I can categorize this data in the quantitative data and qualitative data. Quantitative data is in for which we are having some numerical value. So like I can have a discrete data. Discrete data is like age we are having 25, or BMI we are having value as 25, 30, 39, 40, likewise. So the number of student in my class, I can say it's a discrete data. The number of workers in companies are discrete data. Number of homes run um, runs the foot in a football game. That's again a discrete data. I can have a continuous data. Continuous data is like in case of, as I'm saying, in case of self-driving car, the speed of car is changing at different time. So this is my continuous data. Or height of a children, it is increasing every time. So we'll be having this is a continuous data. The square foot of two-bedroom house depends on different house. My square footage will change in different bedrooms. So that's my continuous data. I can have qualitative data. Qualitative data, as I told you, this is my categorical data. This is nothing but is a categorical data. So categorical data is I can have yes or no. I can have high or low. I can have three categories, two categories, five categories. So depending on the number of categories, I'll divide this categorical data into two. One is the nominal data. Another one is the ordinal data. Nominal data means there is no relationship. Like you are having yes or no, men or women, the colors are blonde and brown. The ethnicity is Asian or something different. So there's no relationship between we are having 0, 1, 0, 1, 2, 2, 3, or the names of city. You are having 10 names of city. So you will be having 1, 2, 3, 4, or 10 categories, but out of these 10 categories, there's no relationship between the categories. Or if in the case of ordinal data, I can have ordinal data. Ordinal data may, like I'm saying, the rank of my student, the rank of a student in my class. So rank of my student can be first, second, or third. So first, second, or third, it is dependent. The second is dependent on the first. Or I can have the letter grades, that is A, B, C, A, B, C. The grade 1 is dependent on grade 2 is dependent on grade 1. Or I can have economic status, so it may be low or medium. So as many is having low economic status, the remaining one will go to the medium. Or if I have another category as high, then I may have two more categories, that is low and medium and high. So when my next outcome is dependent on the previous one. When I'm saying there's a relationship between uh, different categories, then I'll say it is a ordinal data. When there's no relationship between the categories, then we say it's a nominal data. So we can have a numeric kind of data, or we can have a categorical data, as you seen in the previous data set. Then my data can be that the previous example is a simple data where we are having some numeric values or we are having some categorical values. But data cannot be like always simple. It can be a complex data. So what is my complex data? Complex data may be your signals. Signal can be a EEG, ECG signal. It can be a healthcare data, or it can be a noise in environment, or it can be a voice kind of data, or it can be animal sound, or it can be music data. So all is my signal kind of data. In case of signal, then you are having varying amplitude and different frequencies present in the signal. Based on that, you need to, why we say this data is a complex data, because whenever you say there's a original data, lots of noise present in this particular data. So as you see, the signals are not very clear. They are having some shadows. Then next is my image data. I can have a image kind of data. So first is signal. This one is my image. Like in the case of self-driving car, the car has to recognize all the traffic signal while um, moving on the road. So I can have image kind of data. This is my video data. I can have a video data. So in one video, there are multiple frames at one particular time. So this is again a complex data. Then I can have a text data. So I can have the whole book, or you may have a big comprehension. This is the data of tweets. You can have different tweets. Again, this is a unstructured data. Or I can have image kind of data. Out of the image, I want to extract the text. So these all are my complex data. The first previous one, that is a numeric data, that's a simple kind of data. So what we did in the last class, we came to know that is the traditional algorithm. What traditional algorithms are doing, it is giving me the answer corresponding to a different problem. I need to provide a proper exact algorithm, and for the exact algorithm, it is giving me different answers. Whereas in machine learning, what I said is you'll provide the data, you'll provide the answer, and this will give you the rules or the model. So what this model is actually? Model is this will give you a function corresponding to, so I told you there are multiple data. So my outcome is dependent on, like I want to do diabetes prediction. So diabetes is dependent on 10 different features. So because this is dependent, so what I want to do is I want to predict diabetes. So if I represent this diabetes as y, then it is dependent, it's a function of 10 different variables, that is x1, x2 up to xn. So this is a function of, so this model is nothing but is a function, is a mathematical function, is a or you say is a mathematical relationship between the independent and the dependent variable. This one is your dependent variable, and this one is your independent variable. Independent variable, why we call them independent variable? Because I the values of these variable will not change according to any change in different variable. Like if I change x3, then xn is not going to change. But if I change x3, then my y will be y is going to be affected by change of x3. So that is why we say y is the dependent variable, and x1 to xn are my independent variable. So what machine learning model does is machine learning will give you, it will establish a relationship between different variable and number of variable, that is independent variable, or you say the features, between the features to the dependent variable, to the variable what you want to predict. So like we have this kind of data. This is a very simple data. We are having two variables here, x and y. So if you see, if I want to define a relationship, so what I am having in x is my, this is my independent variable. This is my independent variable, and this one is my dependent variable. So if I want to have a relationship between y and x, so if you see y is a function of x, and you can easily see that this y is just twice of previous one. This is a twice of x. You can easily see that it is twice of x. So I can easily define a relationship, that is y is equal to 2 of x. Now again I'll take another data. In this data, if you see what is the relationship, it is y is what? Y is your 3 of x plus 1. Is it 3 of, no, this is 2x plus 3. this is 2x plus 3. The relationship between, so if I want to find out a function, so this one is a bit difficult. If I want to define a relationship between this y and this x, this is a bit difficult for me. First one is a easier one, second one is a bit difficult. Then now coming to the next data. Now we are having this image. What about this image? How do you define a relationship? So manually we are not able to. So if I want y is equal to fx, so we are not able to define relationship between this. So this is where my machine learning algorithms are required. I need to establish a relationship between the outcome. What I want to say, I may say this is a image of a child or image of a African child. So if it is an image of African child, then how do I define a relationship and what are my features that I need to extract with the machine learning algorithm? I cannot do it manually. So coming to my uh, diabetes data set, what we are doing is we want to define a relationship. What is my outcome is diabetes prediction. I want to predict diabetes and it is dependent on my age, gender, then family diabetes, then you have BP and all other features. So I want to establish a relationship through the machine learning algorithm. What I want is I want a relationship between the dependent and the independent variables. So the dependent and independent variable, when you say is a simple data, that's diabetes kind of data. As I told you, the rows are my columns are my feature. In case of the simple data, numeric data or categorical data, columns are your features and rows you say is the number of experiments. So what happened in case of complex data when you are having a signal? In case of signal, what you are having is the signal is defined as signal के case में what you are having is the amplitude of your signal, then you are having frequency of the signal, then you are having wavelength of the signal, or you have a power spectrum. Another feature you can have is the power spectrum. So spectrum. So using these all gives me the feature. What I do is I'll store this waveform in terms of feature. I need to make a matrix of this waveform, and my matrix is again as many waves we are having, that many rows will be there. So your number of rows is the number of waves you have collected, waveform or number of waveforms you have collected, and the number of columns is the features present in each waveform. Features present, and it's not features present, it's the features you want to extract, or features you want to take for your prediction. All features is not mandatory. Then the features present in an image are the lines present in that image or the curves present in the image, like there are curves for eyes, there are curves for nose, there are curve for mouth, and then we are having some low level features. These we say what identified at early layers, that is my low level features. And then we have middle level features, and these we say is the high level features. So based on these features, we'll identify the images. So for images, it's difficult to define the features manually. So what we do, we'll switch for the neural networks, and the neural network, in case of deep learning, we used to provide raw data to the network rather than finding out first the features, then sending it to the model. So we'll be submitting to the model the raw data, and model is responsible to extract my data and then classify. So this is the for the complex data, we prefer going for the deep learning model rather than going for the simple machine learning model. Simple numeric and categorical data can be easily processed by the machine learning models, whereas uh, the complex data like signals, text, images, or we can have different EEG signal or MRI data, all should be processed by the deep learning model. This is the basic difference between my machine learning and the deep learning model. So this all is about today's lecture. Please comment your positive or negative comment or any modification you required in my lectures. Uh, or if you like the videos, please like it. Thank you very much. This all about today's lecture. Have a nice day. We'll see you in the next lecture.